All right, one more theorem I'm going to give you about triangles. One more theorem I'm going to give you. Quick review of the two I gave you on Thursday. I already went over one on the homework. Oh, good. All right, I'm done. Let's try this now. What do I know about the exterior angle of any triangle? Exterior angle of any triangle. Okay, here we go. 15, exterior angle. Okay, and it's equal to the two added up, and it should be, what's bigger? 1, 3, 2. Which one's the biggest one out of those? One's always, the exterior angle is always bigger than either two remote interiors. And then we had a theorem that said if I have 2, 3, and 4, where's the biggest angle going to be located? Here you go, 19. Where's the biggest angle located? Across from what? At the side of 4. Biggest side across from biggest angle, smallest side across from smallest angle. All right. Now, here's what you're going to learn today in groups. That if you're going to have a triangle, and I say, guys, can you put 3 side lengths on? It cannot be any 3 you want. Like if you tell me 12, 15, and 50, that's not going to form a triangle. Okay, the sides have to fit a certain rule, and that's the rule you're going to find in your groups today. All right, so go to the notes there. And as you start reading this activity, it says each member of your group should take turns picking 3 straws. Well, I don't roll with straws in here. All right, what you're going to get instead is pieces of licorice. All right, and hopefully you can act like you've seen food before and not animals, savages. All right, no one's eating anything to the end, and that's if everyone could be mature about this. I am going to give you strips of Twizzler. Your first job in your group is to cut your Twizzlers up into pieces of 2-inch all the way to 6-inch pieces. So you should have a 2, a 3, a 4, a 5, and a 6-inch piece. Whatever's left over, just put off to the side. All right, so that's your first job right now in your groups, using your rulers, and I don't care how you cut them, all right, is to get me a 2, a 3, a 4, a 5, and a 6-inch piece of Twizzler. All right, go right ahead. I'll give you guys a couple minutes to do that task before I move on to the next one. And make sure you know which piece is which, because you're going to record them in a second. Go ahead and cut your pieces off for me. And everyone's got... two, 3, 4, 5, 6-inch pieces. Please come as close as possible. No, 2 through 6. Just 2 through 6. Yep. 2, 3, 4, 5, 6-inch pieces. Okay, it looks like everyone's got their pieces for the most part. Here's what you're going to do now. You're going to take 3 of those pieces. It doesn't matter which 3. record the lengths in your chart here, and then see if you can form a triangle or not. Now, here's what I mean when I say form a triangle. It has to touch vertex to vertex. If there's an exterior angle hanging out, not a triangle. If you cannot get them to touch, don't try to stretch the licorice. It's that length for a reason. It's not a triangle. All right. Find a couple lengths that will form a triangle and a couple that won't. All right. So go ahead, another 2 minutes. Take 3 of them, record them. If it's controversial and you have disagreements in your group, call me over. I'll tell you if it should or not. Okay. Take 3, record the lengths, and say yes or no if it forms a triangle. Find a couple that do, find a couple that do not. What is it? That do and a couple that do not. If you're not sure, let me know.
Did we already do this one? 2, 3, 4. Yeah. 3, 6.
Okay, start finishing up. Just make sure you have a couple no's or a couple yeses in there. All right, it's time to report our results. Let's start with the yeses. Can I get a group that got a yes for 3 of them? Billy, what'd you get? 2, 3, 4. Yep, that's a good one. 2, 3, 4 formed a triangle. Another one in this group?
4, 5, 6.
4, 5, 6. That's a good one. Give me one more yes here. Go ahead, Thomas, your group. 3, 4, 5 should have been a good one. All right. Now let's go to the no's. Give me 3 lengths that did not form a triangle. Guys back there? 6, 2, 2, 3, 6. Yep. That should not have formed a triangle. Mason got one more? 2, 4, 6. Good. Yep. That should not have formed a triangle either. All right. So as you guys are figuring out, you just can't have whatever lengths you want. It won't form a triangle sometimes. Your job now in the next minute, what should I know about those lengths to actually form a triangle? So what's so special about these that never happened here? Okay, talk it over with your group. See if you can find a pattern. See if you can find a pattern right now between the ones that did versus the ones that did not.
The 2 smaller lengths have to be added. Otherwise, they can't move each other.
Okay. Anybody see any patterns here? Do we see when it will, when it won't? Go ahead, Thomas. What do you got?
The sum of the two smaller sides has to be greater than the total of the largest side.
Correct. Okay, and I'm going to even make it a little bit more detailed than the sum of two smaller sides. It's the sum of any two sides. Okay, you take any two sides, it has to be bigger than the third side. Now, notice what we just said. We said bigger than. We didn't say bigger than or equal to. Everyone see 2, 4, 6? That didn't work because when you add up in 2 and 4, that equals 6. It has to be greater than the third side. And that is what you're going to write down in the box down below, which is called the triangle inequality theorem, which says the following. In a triangle, sum of two sides. So if I'm asking for the sum, I'm doing adding two of them up. The sum of two sides must be greater, not greater than or equal to, must be greater than the third side. Only way you're forming a triangle, only way. Sum of two sides greater than the third side. Make sure everyone's got a calculator out here. I don't want to waste time getting one out because I know you'll need one coming up here. Not right now, hopefully, but by the end of class. All right, I'm going to go around the room here. If you take a look, flip over your packet there. Question number 1, I've gotten 5 different side lengths of triangles. With those side lengths, will I form a triangle or not? Okay, so I got 1, 2, and 3. I'm going to form a triangle, and then if you're going to say no, back yourself up with why not. Okay, if you're going to give me a no. So what side lengths of 1, 2, and 3, will that work? 18, will that work? Why not? What's wrong with it? Which two sides? So 1 plus 2 is equal to 3, not greater than 3, so it won't. Now, could you say, hey, what about 3 plus 2? Isn't that bigger than 1? Yeah, but as long as you have one that doesn't work, it's a no. All right. 2, 4, 5. 2, 4, 5. Good enough to form a triangle? We'll get it there eventually. 2, 4, 5. Number 4, good enough?
Yes.
Yes, it will. And you don't need to tell me why. Just yes is good. 5, 5, 6. What do you got for me? 13. 5, 5, 6? Yes. And for also a bonus here, what type of triangle is it? Isosceles. Look at that. All right, next one here. 8, 13, 21. Is that going to be good enough? 24? Why not? Yep, it equals 21. It should be bigger than that one. And then finally, 10, 20, 25. 10, 20, 25. What do you got for me? 24? Yep. So we're good to go. Any issues determining the triangle or not? Last thing I need you to do with this theorem I just showed you is tell me possible lengths of a third side then. So for number 2, we have a triangle, and the two sides are 4 and 7. Four and 7. The third side can't be any number. We know that now. It can't be any number. What I need your help with is give me numbers it could be. Give me numbers it could be. So I got 4 and 7. Give me other values this side could be. Because you can't say 100. Can't say 1. It's not going to work. It's got to be certain values. Here we go. 1, start us off. 10 would work. All right, I'm going to list them all out. You're going to help me list them all out here. 12, give me another value. Oh, one job, right? 16, another value. Would 11 work? 9. Why wouldn't 11 work? 4 plus 7 is 11. It's got to be greater than that, but 9 would work. Yep, hopefully now we're seeing in a pattern, so I have an idea of what people are going to tell me now. 2. All right, let's keep this going because it can't go on forever. Somebody's going to get stuck. 9, what's another one? Oh, all right. I can do 4. Okay, I'm just going to, it's everything in between. No escaping out of this one. But can I go lower than 4? Can I go lower than 4? Can I go 3? Why wouldn't 3 work? 3 plus 4 is 7. It's got to be bigger. We just said we can't go 11. So basically, I have all my values here, right? All right. I do not want you to list them all the time because that could get pretty ridiculous if, let's say, this is 2 and that's 30. You're not going to list them all out. So instead, hopefully you did this last year in algebra. You ever heard of compound inequalities? Where you had 2 inequalities here, and you told me x was greater than this number, but less than that number.
Isn't there another way we could do it? It's like the brackets.
Yeah, we're not. No, I don't want to do it that way. I want to do it this compound inequality way. So here's how I want you to write this. I'm going to go S for sides. S has to be, and this is how we're going to write this third side every time. Homework tonight. Maybe if I could do it. S has to be between what 2 numbers now? This is where I need your help. Here are all the possible side lengths. S has to be between what? And you can adjust my inequality if you want as well. What's up, Thomas?
Be able to say 3 has to be greater than 3 as a lowest.
I don't know. I'm asking for suggestions because I know my lowest one here is 4.
But you can also equal 4.
So you want me to adjust that and put an or equal to there?
Or you could say 3, because anything above 3, even decimal, would still be valid.
Okay, you took my steam away. Nobody write this down because here's what I get. Put 4 and 11. Put 4 and 10. Sorry. Put 4 and 10 and put the or equal to there, and you're good to go. But the problem is. Okay, 10. We know it's a 10. Here's the problem. Could this side be... Okay, I'm going to flip out here in a second. 3.7. Is that still okay for a side length? 3.7. Well, what's 4 plus 3.7? Is that bigger than the third side? But is 3.7 in the inequality? No. It's got to be, though. It's a possible side length. So 4 and 10 aren't going to cut it. All right, 4 and 10 aren't going to cut it. Either is this pen today. So instead, Thomas, go back to your original suggestion, which is not 4 and 10, but 3 and 11. Yep, S is between 3 and 11. Now, that took a lot of work to get there. And you know what? I'm not expecting you to do all that work. Here's why. Could somebody tell me the original 2 side lengths I gave you? What was the original 2 I gave you? 4 and 7. Oh, look what our range was. 3 and 11. Anybody want to tell me a little quick trick what I could do to the given sides to get to my range of values? Caleb, what do you see there? 7 minus 4, everybody, gives you what? 3. And how do I get to the other part? 7 plus 4? 11. That's how I can get to that range pretty quickly. I am not going to expect you guys to list them out anymore. Okay? Questions? Yep.
Will like subtracting and adding them work every time?
Every time. Always. So 9 and 17 now. If you have 2 sides of 9 and 17, your side should be between what on your inequality? Here you go, 19. Here we go, 17 minus 9. Between 8 and what's the upper value here? Oh, nope, I'm going to keep going. 19, look at that. Never mind. 20. I just heard 3 values there. 9 and 7, 26. There you go. And then what happens if I had 11 and 20? Here you go, 25. Yep. So that side's got to be bigger than 9, but less than, what was your other number? Sorry, 31. Yep. Questions there? All right, and last thing we got to do is what happens if I ask you to graph it and ask you if it's a triangle or not. So go ahead and graph triangle QRS. And the response isn't, I could graph it, that means it's a triangle. No, we need a little bit something more mathematically. Anytime I can put this into the notes, I am. Sum of two sides needs to be bigger than the third. How are you going to find the lengths of the sides then? Yep. Anytime I could add it in, just for time's sake and so it's not as annoying as it already is. QR, these three groups right here on the left, you guys are responsible for the distance at QR. Check with each other before you report back. QR, you guys right here, these two groups, you guys have RS. Last three over here on the right-hand side, you have QS. All right, you guys have QS over here on the right. If you don't remember the distance formula, ask somebody in your group. Odds are somebody will. We have been using it forever here, so. This is what's going to be expected tonight, too. You do have one graphing question tonight. This is what's going to be expected tonight. Okay, let's report back. Most groups are done. QR, I had 3 groups working on QR. What was it? Square root of 17. Yep. Write it down, please, if you weren't responsible for it. Make sure you record it. QR, radical 17. Middle 2 groups, what'd you guys get for RS? Square root of 34. Record it, please. And how about the QS group over there, the 3 groups? Square root of 17. Looks like I gave you an isosceles triangle, if it is one. All right, so using these side lengths, is it a triangle or not? Well, I don't need to test out every 2 sides and see if it's greater than the third. I just need to do the 2 smallest ones. So what are the 2 smallest sides up here? Radical 17 and radical 17. So what I need to test is the square root of 17 plus the square root of 17, is that bigger than square root of 34? And many of you that forgot your algebra skills from last year are going to say, no, they're equal to each other because you're doing 17 plus 17. That is not how radicals works, ladies and gentlemen. You just don't add what's underneath. That's why you have your calculators out right now. So everyone go to your calculators. Yes. I don't know yet. I got to compare them right now. Right? That's why I just said I'm going to compare them. Are they equal, greater than, less than? That's what I'm trying to figure out. Okay, and then I'll put, using my calculator, everyone go ahead, radical 17 plus radical 17. See that number right there? Now put in square root of 34 and compare those 2 numbers. You will see that they are far from equal. And what are you noticing? Is radical 17 plus radical 17 equal, greater than, or less than? It is greater than, so that tells me Triangle QRS is a triangle. All right, I picked this one in particular. You cannot add the numbers underneath the radical. That's not how this rolls. Go to your calculator and look at the decimals. Questions there? Okay, as long as we can, again, be mature about it as you're starting the homework, you can start divvying up your licorice and eating it. If you don't want to eat it in your group, please dispose of it in the garbage. Don't leave it on the floor. 1 second, Tom.
Alright, I'll take this one down. They're probably in a bag.